Hi, everyone. I'd like to welcome you all to today's session. Glad to see so many of you joining us today. My name is Drew Demokas. I'm a creator and developer advocate for Unity's technical marketing team, and today I'm joined by Antonia Forster and Abdul Rahman Musa, who will be leading today's presentation. Additionally, we'll be supported in the chat by Elizabeth Guzman. So to break today's session down, we'll begin today with just a brief overview of Unity and then continue into our main topic. There's also going to be a survey available, and we really want to learn from you about how we can improve our presentations, so please fill that out for a chance to win a $150 Amazon gift card. And after the presentation, we'll be opening things up to some Q&A, so please post any questions in the Q&A section. So with that, let's get started. If you're joining us for the first time, at Unity, we believe the world is a better place with more creators in it. This is our core philosophy, driving us to help serve the global creator community. We want to help solve the toughest engineering, data, and operational problems so that digital creators can create and operate. Unity is the world's leading platform for creating and operating interactive real-time 3D content. Our platform provides a comprehensive set of software solutions to create and operate interactive real-time 2D and 3D content for mobile phones, tablets, PCs, consoles, as well as augmented and virtual reality devices. But what do I mean by interactive real-time 3D? Let me break it down. The way we consume media or engage with any content is changing from static to being more interactive. What was asynchronous is also becoming real-time. So this one takes a little more to explain, especially in the world of media and animation. A lot of things are asynchronous. So if you were to render out a film and then view it, that's asynchronous. You can't make any changes as it's happening. You'd have to stop and re-render the entire thing. So one of the big benefits of Unity is its power to render really amazing visuals in real time. Things like lighting and physics are calculated immediately, so you can make dynamic changes, like moving this tree around in my GIF here, and see the physics and lighting behaving accordingly. You don't have to wait for a whole film to render in order to make those changes. And finally, what was 2D is now 3D. So rather than viewing content on the screen, we can see it in a real local environment, or we can be inside a virtual showroom or gallery. Working with 3D content, like what we see here, provides a number of benefits. First being immersion. As our world's in 3 dimensions, we move and think and experience in 3D. So compared to traditional static content, the extended spatial presence of being in a virtual environment it brings enhanced problem solving, higher levels of engagement, understanding, and much more. But with that, I'd like to introduce today's speakers. Antonia is an XR technical specialist with a decade of experience in public speaking and several years of experience developing XR applications. In her role at Unity, she works across industry verticals, from automotive to architecture, creating demos, delivering talks, and using XR to push the boundaries of what's possible. And Abdul Rahman is the technical product manager for PaceLab Weaver. He is responsible for defining the product roadmap and vision, identifying and presenting innovative product solutions, managing customer projects, and coordinating product releases with marketing, sales, and development teams. So if you're ready, Antonia, please take it away.
Perfect. Thank you so much, Drew. Thank you for that fantastic introduction. And thanks everyone for attending. So my name is Antonia Forster. My pronouns are she, her, and I'm an XR technical specialist for industry here at Unity. XR means extended realities, and it's really a big umbrella term that covers technologies like virtual reality, as well as augmented reality, and the space in between. So my work involves using this technology to revolutionize a range of industries and delivering webinars, just like this one, to enable you to do the same. I would love to know which industry you work in and how you're using Unity. So I'll give some details at the end of this talk. You can find me on Twitter primarily. So please do reach out and let me know which industry you're in, how you're using Unity if you see this webinar. Today, specifically, I'm here to speak about VR safety training and site induction. And I have 2 goals. Firstly, I want to show you what is possible with this amazing tech and how it's revolutionizing your industry. And then I want to give you the knowledge and tools that you need to get started right away. This is a sneak preview of what you will be able to make by the end of this talk. First of all, we're going to use a point cloud scan of a factory to validate the position of a piece of equipment. I'll show you how to implement clash detection to check whether an engineer can safely access and operate a piece of machinery, or whether that would cause a clash or collision in that specific location on that site. This can, of course, save a vast amount of time and money in relocating equipment. Then we'll take that same scene and implement VR safety training on top, so that you can teach the worker how to safely move across the job site, hazards that they should be aware of, and also how to follow the correct procedure to operate machinery. So here's what we'll be covering today. Firstly, why do you need VR safety training? What are the benefits and what's the return on investment? We'll be looking at case studies from industry leaders and looking at what is possible just using the Unity editor alone. Then I want to show you what's possible with 2 additional pieces of software. Both of these are verified solutions partners of ours with products that work on top of the Unity editor. First, we'll look at Interact by Light and Shadows and some of its capabilities, which includes importing point cloud scans of your environment, implementing clash detection for validating equipment position or safety, VR training, and even things like ergonomic analysis. Then I want to look at a second solution called Weaver. Weaver is also a solution for VR training, but is quite a different set of tools than Interact. Specifically, it allows you not only to build VR training, but also to deploy it at scale across your organization, manage who is accessing it, receive analytics on their performance, and so on. So you can go from a proof of concept to really an integrated solution across your enterprise or organization. So first of all, as Drew said, what drives us here at Unity? Well, we believe the world is a better place with more creators in it. So everything we do is focused around enabling users like yourselves to create any kind of content you can imagine. That could be VR, AR, could be a kiosk, really anything you can come up with, a phone, a tablet, or a monitor. So we build the tools so that you can build the future. There are 1.5 million monthly active Unity creators and 5 billion downloads per month of apps built in Unity. So it's extremely likely that you've used an application built with Unity, even if you weren't aware of it. This isn't just technology that will revolutionize the industry in the future. It's happening right now. 10 out of 10 top automotive manufacturers are already using Unity. Our core platform, the Unity editor, is a real-time 3D development environment with built-in lighting and physics. Essentially, it's a sandbox where you can build any kind of content that you want. I want to share this video or an excerpt of a video just to show you some of the use cases for Unity in your industry specifically, and how it can benefit you at every stage of the product lifecycle.
Number one, you have the design, the aesthetics of the building, the architecture.
It's interactive. Select your wood grain if you want oak versus cherry. Add lighting and actually see how far into this space the natural light gets so that we can start to feel the comfort of the people that will one day experience that building.
Next, we have the engineering, how it will be built. Foundations, structure, interior build out, different systems, mechanical, electrical, plumbing. When you see something in scale in the real-time engine, it affects your decision-making. You think about logistics, mobilization, you think about safety differently. Third, you have construction, the actual excavation and the erection of the building itself.
With on-site construction, augmented reality, we can actually overlay the entire building in front of the developer. It gives us an opportunity to solve problems before they arise and to give our clients what they want.
Fourth is marketing. A lot of times you're building condominiums, office space above, retail space below. You need to market, you need to sell, you need to get tenants inside of your building.
Well, we have this virtual, dynamic, real-time environment now that this potential client can go and walk through to sell the space.
And finally, the maintenance, maintaining the day-to-day of the building and all of its systems.
We're able to do photogrammetry of the infrastructure behind these walls before the drywall goes up. So we can be minimally invasive when we need to inevitably go fix that pipe. The use cases are endless. If we allocated enough resources to this, we could change a $10 trillion industry. We can change how buildings are built.
Without Unity, all this wouldn't be possible. Let's just put it that way.
So as you could see in that video, Unity can really be leveraged for a whole range of use cases. So in this webinar, let's specifically look at VR safety training. What problems can Unity solve and what benefits does it bring to you? Well, last year's Safety Management in the Construction Industry report by Dodge showed that the most effective safety training is site-specific. At the moment, 75% of contractors rely on supervisors or foremen to conduct training for them on site, as opposed to using a third-party trainer or online methods. Contractors report material benefits from excellent safety practices, not just lowering injury rates, which is fairly obvious, but also a higher willingness from job site workers to report unsafe conditions, higher standing in the industry, a better ability to contract new work, increased project quality, and higher staff retention. But the classroom-based learning methods that are most often used, such as listening to a talk, watching a video, or taking a paper test, have significant disadvantages. Since those are passive methods of learning, the learner may be distracted or not invested, which leads to slow learning, poor retention, and later higher rates of error and even injuries on site. Learners typically remember just 5% of material that they've heard in a talk. Also, it isn't adaptive. One person may be bored while another person is struggling to keep up. Classroom training often requires everyone to be on the site, unless you're relying on people doing training remotely. And finally, it relies on a trainer or a foreman or member of staff to be available. The very best training possible would be to actually practice the activity hands-on that you're learning. But this isn't always possible. And that's particularly true in the context of safety training. You can't always send someone up in a crane or a telephone pole to learn on the job or put them in a dangerous scenario. And trying to simulate this scenario in real life is expensive. So more often, a site induction won't involve simulating any scenario. It will just be a walk around the site pointing out hazards. That isn't hugely engaging, and there's also no way to ensure someone is actually paying attention throughout, apart from giving them a quiz at the end. And again, a site tour relies on a member of staff being available. So what's the solution here? Well, many industry leaders are finding that the ideal solution is virtual reality. 81% of companies, perhaps including your own, have said that VR and AR will become mainstream in their company within 3 to 5 years. The vast majority of adopters are investing more in VR and AR every year, and nearly all businesses who haven't yet adopted this tech believe that it will revolutionize their workflow. A 2020 PwC study into the efficacy of VR training found that VR-trained employees are 275% more confident to act on what they've learned compared to those learning in a classroom. VR learners also learn 4 times faster and were shown to be more engaged and emotionally invested in the content. Not only that, but VR training courses are more scalable. The same study found that VR training achieves cost parity with classroom-based learning when you have over 375 learners. And that parity occurs even sooner if your organization is global, so training needs to occur over multiple locations, or if your employees need refresher courses and so on. So if this applies to you, then VR training really is a no-brainer. Faster learning and higher retention are just 2 of the many benefits. VR training is adaptive. The trainee can go at whatever pace suits them. You can easily get analytics to track every employee's progress and see specifically which areas they're struggling with. It's location independent and it's schedule independent, so it's perfect for busy global teams. And this results in lower cost. In architecture, engineering, and construction, there are even more knock-on benefits. New workers can be inducted onto a site without having to actually be on site, and that frees up the number of people there. It saves time, it reduces risks. VR allows training scenarios for edge cases and things that wouldn't be possible or safe to simulate. Also, you can make an employee feel as if they're at risk without ever putting them in any danger, which really drives home the importance of health and safety protocols and PPE. It's also repeatable. Training can be refreshed throughout the year or made available year-round. You can take one training scenario and customize it, making it site-specific, and you can do that for as many sites as many times as you want. And finally, it's perfectly consistent. You know you are delivering the same quality of training every time. So who are the industry leaders that are already using this technology, and how has it worked out for them? Skanska is the 5th largest construction company in the world. They commissioned a creative agency out here to create a realistic VR safety training program for their employees using Unity. This resulted in increased worker awareness of job hazards, fewer accidents, and higher productivity. Behavioral science shows that VR training leads to the lasting behavioral changes that we really need to see from safety training, because you can make participants feel at risk in a simulated environment without endangering them. Another one of our clients, Lockheed Martin, uses VR not only for training, but also for validation, to discover issues with products before manufacture. They saw a 10-fold return on investment and avoided more than $10 million in associated costs. The company also saved $50,000 on travel expenses alone by enabling employees to train and collaborate in virtual reality rather than having to travel. Laing O'Rourke, one of the largest privately owned construction companies in the UK, used Unity to create VR safety training. They created a crane simulator to train their lifting teams. The training scenario is multiplayer. The crane driver is sat inside a virtual crane and has to follow a banksman's instructions. This not only improved communication on their lifting teams, but also between different teams and had knock-on benefits across the whole organization. Vodafone commissioned MakeReal, an immersive content developer, to create a working at height training experience in VR. Now, the target of this training wasn't the actual crew, but their managers, to increase empathy and raise awareness around the dangers of the job, to help them understand the risks that their workers face and the importance of PPE. This community of stakeholders is large and works across 20 different territories around the world, so it would have been impossible to get them all on site, not to mention the obvious danger of trying to simulate this in person. The experience was highly successful. In fact, they found that many people couldn't actually make it to the end of the scenario because it was so immersive and a bit frightening. So they created a second scenario where the user is on a rooftop instead. This training won the AI XR VR Awards in 2019 for VR training and education. TfL, the government body responsible for most of the transport in London, approached MakeReal to create a VR site induction and health and safety training for a large construction project in Crossrail. This allowed their site induction to be carried out remotely, so new starters had all the knowledge they need before they came on site. This was also used to teach new workers about site-specific hazards they might encounter, and is now used to show potential apprentices what working at TfL looks like. As we saw earlier, VR learners have more confidence, learn more quickly, and retain the knowledge more than learners using a website, a classroom, or learning from a talk. So all of these solutions were made just using the Unity editor with no additional software. But how do you recreate that success yourself? Well, typically, you've had two choices historically. One option is to develop the software yourself in-house. This means the training will exactly match your needs, but it does require a developer, perhaps a team of developers, to create the content. If you're deploying it at scale, it also requires appropriate infrastructure to distribute the training, to track analytics, and to manage and maintain the content. Or alternatively, you can pay someone to create the content for you, such as a creative agency. In that scenario, you'll often have to pay per module, and it also means you're tied to that vendor for maintenance. Neither of those options are very scalable or flexible, and both routes can be expensive. So what's the third path? Well, this is where our purpose-built products and software partners come in. Unity has a range of both native products and partner solutions that provide you with specialized tools and workflows to achieve specific tasks. The two solutions I want to focus on today are Interact and Weaver, which are both solutions created by partners of ours. Interact is made by our partner Light and Shadows, and Weaver is made by our partner Pace. Both of these software solutions are a special set of tools that allow you to create VR training without any coding skills needed. Each offers something different, and they can be used in combination, as we'll demonstrate a little bit later on. I'm going to show you Interact first and demo how you would get started with it, and then I'll speak more about Weaver afterwards. Interact, as we'll see in just a moment, is a tool to provide real-time simulation of anything that involves humans. So every process in a factory or a job site that involves a human, whether that's assembly, maintenance, safety training, or site induction, you can use Interact to validate or implement that process in VR. For example, you can jump into VR and manipulate equipment, see a cross-section or an exploded view, and you can create training to train engineers on procedures, to check that they're able to safely access different parts of the equipment. You can even use it to find out the best way to maneuver a piece of equipment or a pre-manufactured product through your factory or through a busy job site. The features that Interact boasts include CAD and point cloud data import, a highly accurate physics simulator, so you can run complex safety simulations, support for multi-user collaboration, and the ability to build VR training. Since Interact supports hand tracking and full body tracking, it can also be used for real-time ergonomic analysis, as you can see in this video, which means you're able to validate and design workplaces in collaboration with the specific people who will be using them. Getting their feedback at this stage is invaluable because management might hesitate to make changes to workstations after manufacture because of the cost. But at this early stage, they're much more able to give the green light. So just like the Unity editor itself, Interact is flexible and can be used for a wide range of functionality. In this demo, I want to show you how you would use Interact on top of the Unity editor to import a point cloud scan of your job site, implement clash detection for safety validation, and how you could test this in VR. The first step would be to obtain the Interact software package, which you can do from the Light and Shadows website or on the Unity product page. I'll show you the link for both of those at the end of the talk. Once you register, you will receive a package and a product key via email. You'll also need to sign up for Unity and download the Unity Hub, which is completely free. And finally, you'll want to take a point cloud scan of your environment, which is now very easy to do on an iPad or an iPhone, and then save this to your machine, ideally in a .e57 format. From there, the next step is to open the Unity Hub and start a new project. For compatibility with Interact, I recommend using Unity 2019.4. If you don't have that version, click Installs, then Add, and select the Unity 2019.4 LTS from here. So choose your version of Unity, then give your project a name and destination. Leave the template as 3D and click on Create. Once the editor is open, you'll want to import the Interact package. To do this, just navigate to where you've downloaded it and double-click on it. In this window that pops up, click Import. This may take some time. A window may appear displaying recommended project settings for Steam VR, and if so, just press Accept All. Now that Interact is imported, you need to validate the license. To do that, click on the new Interact button at the top, and then License Manager. If you're using a standalone license, you'll receive a product key, which you can enter on this page. I've already entered mine, so I'm just going to close this window. Now we're ready to start using Interact. To set up a new scene, click Interact, Create New Simulation. You have two environments to choose from, the laboratory or the factory. Next, you want to select the platform or device that you'll be building to. The supported options are Vive headsets, Oculus headsets, Windows mixed reality headsets, a traditional desktop setup, or a cave system. Interact also supports hand tracking using a Leap Motion device or Manus VR gloves, or alternatively can support full body tracking with an art suit or a Light and Shadows suit. I'll be building to the Quest 2, so I'll select Oculus here and click OK. The scene is now set up for VR, and we could jump into the headset and look around, but there isn't much to look at yet. So for this particular demo, I want to import a point cloud scan of my environment. To do that, just click on Interact on the bar at the very top, then Import and Point Cloud. Again, to import, just select your point cloud and press OK. The point cloud is now visible in the hierarchy, but we can't see it in the scene. And if that's the case, it may mean the point cloud has an origin that is far away from the scene's origin. To fix this, click on the point cloud. Then in the inspector on the right-hand side, find the OctoPCL tree server component and click Align to Floor. It now recenters and is visible in the scene. We can scroll by using the mouse wheel. We can look around by holding down the right mouse button and pan by holding down the middle mouse button. We can move this whole point cloud by clicking it in the hierarchy, then pressing W and dragging it using the arrow gizmo. Now that I'm in a good position, I'm going to add a model. You can import your own CAD data or dumb geometry 3D model of any equipment you want to validate. Interact also has a small library of models that you can use. So to find it, click Interact, Industrial Library, and I'm going to select a robot called the IRB 6700. Now we can find it in the hierarchy, click on it to select it, and use the Unity gizmo again to position it wherever you want. Now we want to set up clash detection. To do this, select the physics manager in the hierarchy. Scroll to the bottom and find the component called OctoPCL collision scene. There are two fields here. The resolution value is in meters, and this is a bit like chopping your scene into cubes of that resolution. If you choose a lower number, the collision detection will be more precise, but it will also take longer to launch. So I'll leave it at 0.1 for now. The minimum point intersected field is the threshold at which your system will decide there is a valid intersection or collision. If you set this higher, the system can tolerate more noise, which is useful in ignoring false positives if your point cloud is noisy. And the lower the number is, the more sensitive the clash detection will be. So I'm going to set it to 2000. Now select the model that you want to check intersection with. In our case, that is the robotic arm on the left-hand side. And click on Add Component, OctoPCL Mesh Collider. Also add the component called Mesh Collider Renderer. Look at the Mesh Collider Renderer component, and if that field at the bottom is empty, just drag in the OctoPCL Mesh Collider as a reference. Note that this will only work with a mesh collider, not a box or capsule collider. Finally, right-click on the model and select Interact, Point Cloud, check intersection. Now click Play, and we can see that the parts of the robot that intersect with the point cloud will turn yellow. So here we can see that the base is colliding with the floor. Please note that we cannot at this point move the model around in the scene with the arrow gizmo like we did before. That's because Interact physicalizes the model, which means we can move it only within the constraints of its realistic range of movements. In order to enable movement in the editor, decide which part of your model you want to move. So I'll choose link 6, which is the very end of the robot arm, and click Interact, Add Manipulator, and press OK. An object called an XYZ manipulator will appear in the hierarchy. Click Play, then head back to the scene view. And if we now drag the XYZ manipulator around using the arrow gizmo in the editor, our entire model will manipulate itself appropriately to place the end of the arm as close as it can to that manipulator's transform. We can manipulate the model in this way and see where it would clash with the scanned environment. For example, in this environment, we can see that when the robotic arm is moving left and right, this part at the back is colliding with a pillar. If this was a rigid part like a handle, it could mean that this particular position is totally unsuitable for the machine and it has to be relocated. Or if this is a flexible part like a hose or a cable, you could expect this part of the machine to experience more wear and tear, and that knowledge can help you to optimize your operations. Now we want to make the machine grabbable in VR rather than in the editor. To do this, we must first remove the XYZ manipulator. To do that, we're just going to right-click on it and press Delete. In order to make a part grabbable in Interact, we have to check if it has been physicalized. We can check that by looking for this cog icon, which means that it has, or alternatively, by checking in the inspector to see if it has the XDE rigid body component. If it has either of these indicators, we know that we can make the part grabbable. To do this, just right-click on the part and select Interact, Assembly, Make Part Grabbable. This adds a component called an XDE ASB part. If we press play and then jump into a VR headset, we can now grab that part of the machine and manipulate it, just like we did in the editor. If we move the robotic arm in a way that causes collisions with the point cloud environment, we can see that the clash detection is still operating, and it will turn the part yellow to warn us. Not only is that an excellent way to validate whether a piece of equipment can be safely operated, and to teach the worker how to operate the machine safely, but this workflow also allows you to see whether a piece of machinery can be maneuvered across a site without causing any collisions. Since point cloud capture is now possible in just 1 or 2 minutes on something as simple and inexpensive as an iPad or an iPhone, you can validate these scenarios not just with a theoretical model of your site, but a scan of how it actually is that week or even that day. It also allows you to see whether engineers or on-site workers can safely access the specific parts of the equipment that they need to access, whether that's for routine procedure or maintenance. Interact includes tools to allow you to build VR training. So we could take this same demo and then, continuing in the same tool, turn it into a VR safety training application, perhaps to create a proof of concept and to get buy-in from your organization. But one of the big challenges is scaling beyond that proof of concept project and bringing VR training into real production at scale at an enterprise level. How do you do that? That's where a different product called Weaver is really able to offer a huge amount of help. I'll now pass over to Moses, the technical product manager at Pace, to tell you more.
Thank you, Antonia. My name is Abdurrahman Musa. I am the technical product manager for PaceUp Weaver. As the title states, Weaver extends Unity to a complete training solution. Allow me to introduce you PaceLab Weaver platform. PaceLab Weaver consists of three main modules: the Weaver Creator, the Weaver Manager, and the Weaver Player. The Weaver Creator is the authoring tool, which is built on top of Unity, where you can build any XR training without the need of writing a single line of code, simply by creating a block of step. And you could define the title of that step and specify an enter actions or exit conditions or exit actions by dragging and dropping the game object from the hierarchy to the procedural inspector. With the Weaver Creator, you have all the assets necessary to create different behaviors like grabbing, throwing, connecting, and much more. You can create as many steps as you would need, and then just simply link them together. With that, when the training is completed, you would have the overall view of the procedure. You could have a dynamic or a linear workflow. Now, navigating to the Weaver Manager, the Weaver Manager acts as the central nerve of the platform, where it is tying together the authoring tool and the execution tool. With the Weaver Manager, you can add a new user or create a group of users from the invited ones. You can assign them a specific training, either from the library assets or by uploading a new procedure that we have just created from the procedure creator. By dragging and dropping the file, you can specify the description and the accessibility of that particular training. Moreover, you're able to create a collaborative training scenario by choosing the procedure, inviting the users or the group, and adding the instructor for that training. You could see the list of invited people to this particular training. Moreover, you can gain a training insights analytics about the individual user or about the group of users. Now, navigating to the Weaver Player, which is the execution tool, it acts as the central application to access all your XR content from a single united interface. You can see the procedure, select the training that you would like to execute, and choose the execution mode. For example, we're choosing the guided mode in that case. So this is a use case where we're training the pilot to inspect the components of an aircraft before a departure. With the guided mode, there will be guided annotations and billboards and audio. Now with the assessment mode, we have simulated the real-time pressure, where they have to inspect the components of the aircraft before the departure. When it is damaged, the component, then that means the aircraft cannot you cannot fly with it. So it's not ready to fly. If it is not damaged, then it is ready to fly. Once the procedure is completed, you can see a real-time feedback about your execution process within the training itself. Now, seeing what is PaceLab Weaver about, let me show you how we can get started by building a new procedural training with Interact. So first, we are creating a new step, and then we're defining an enter actions. For instance, we're adding a text-to-speech, where we will have a welcoming message to welcome the operator to the training field. And then we will add a show billboard expert. With the show billboard expert, we do have a lot of different variables and configurations that we could change. For instance, we can define a sample. We can choose an icon to display in the billboard. For example, we're showing an info image. We can define the title, which is a welcome message, and the text that we would like to display, which is the same as welcome to the site induction and safety training text-to-speech. Moreover, you would have different actions that you could benefit from. For example, choosing a start point for the billboard or an end point for that. choosing a word size dimension, and the visibility of the billboard. So when you're setting the limits of that, you're able to see the billboard in its real scale, depending on your actual position in the virtual scene. So the closer you are, the smaller it will be. The further you are, the larger it will be. Once we created the first step, we can create the second step. So it is similarly as we have done before, adding a billboard and a text-to-speech. But in that case, we're showing a caution message to ensure that the operator is wearing a protective equipment. And we're specifying the same criteria variables that we have defined in the previous step. Now, moving on to the third step, we're adding, again, a text-to-speech, but here we are informing the operator to move closer to the robotic arm machine. So in that case, we will show a simple billboard, for instance. And you could notice the difference. With a show billboard, you don't need to configure all these different variables. So all what you need to do is just to drag the target and specify the text that you would like to display. Once you hit on the preview button, you would be able to see the preview of this billboard in this scene. You could position it the way that you would like to and where you would like to see it the best. Once you do that, you can save this and define an exit condition. So in this use case, we're adding an exit condition to ensure that the operator is standing at the right position and have moved closer to the robotic machine. So we're using an object is an area, which is a condition coming from the Weaver asset. All what you would do is drag and drop the VR camera and specify the area that you would need to use. We're linking now the steps together and moving on to the fourth step, which is similarly adding a new text-to-speech where we are informing now the operator to make sure that the robotic arm machine is off before touching it, and giving this as a warning billboard sample. So we have changed the sample of the billboard and chosen a warning message indication. We will position this in the scene and define the exit condition in that case. To do that, we are adding a visual inspect impact. In that case, we are specifying the distance and the time for the condition for visually inspection. Moreover, we will move to the fifth step in that case, and we're adding the direction to allow the operator to grab the game object from the endpoint of the robotic arm machine. To do that, we're doing also an annotation, which is the billboard, and specifying the conditions for that. So what is interesting about this part is where the interactions come from. So we're using the grabbable behavior that have been defined and coming from interact. We're specifying the condition, in that case, when we will drag and drop the link 6 game component. So as we see here, we're drag and dropping the game object and choosing the behavior grabbable, which is coming from interact, and ensuring that it is true. Once this condition is saved, that means in order to move to the next step, the operator has to grab the object from the robotic arm machine. Now we are moving to the last step, which is adding a wait time in the procedure training so that the operator have few seconds to move in the scene. And then we're providing the congratulations message. So in that case, the operator will know that he have completed the training scenario. Now, once the procedure is completed, we need to upload this to the manager. In order to do the upload, we have to navigate to the upload button and build the asset bundle. So navigating to the upload button, and we're building the asset bundle of this particular procedure. This may take some time. Once the upload and the build is completed, we can now log in to the Weaver Manager using our credentials. Now, from the Weaver Manager, we're able to create a new group. So let's name this group as Weaver plus Interact Demo. And then I'll add myself as a user for that particular group. Once we hit the button create, we see the new group that we have created, and then we will navigate to the procedural tab. There we will upload the file by drag and dropping the procedure that we have just created from the Weaver Creator. Then we can click next, and then we can specify the description of that particular training and the name of this training. Then we can assign this to this group, which is the one that we have just created. Once we click the Save button, we see the overall description as highlighted below, and then we can add a new user or check the accessibility of existing users in that case. So let's add Antonio, for example, as a new user for this particular training. We're choosing the group, and we just send the invitation. Now, Antonia have received the invitation to join this particular training. We will see, in that case, later on, how we can execute this training from the Weaver player. So this is the Weaver player interface from the virtual headset using the Oculus Quest. We see the group that we have just created, and we are choosing the procedure that we have just uploaded. We see the overview description in that case, and we will just select the execution mode of that particular training. Once we hit the start button, now we are inside the virtual environment that we have just created together. We see the scene, the model that we have imported, and the welcoming message that we have created. Now we're displaying the caution message to inform the operator that they're wearing the protective equipment. Now we are guiding the user to move closer to the robotic arm machine. So once we're moving closer to the robotic arm machine, it will trigger the next action or the next step, which is giving the warning message to inspect the game object and make sure it is off around the surroundings of this model. Once the inspection is completed, we are triggering the next condition and guiding the user to grab the endpoint of the arm machine in that case. When we're grabbing it, we will be able to see the interaction that is coming from interact. And we will see the collision if it is crashing with the components around it. And we see the highlighted color in that case. So with that being said, we are able to create a VR training scenario using Weaver Creator plus Interact. With all this being said, Weaver is your complete training solution for any XR application that you would like to develop at your organization. And now I'll be passing back to Antonia.
So hopefully now you all attending here today have a better understanding of the benefits of VR safety training and site induction, a good understanding of the different options available, the knowledge required to pick the tool that suits you, whether you want to use Interact only, Weaver only, the Unity editor by itself, or all three in combination, and also the ability to use one and build on top of it with the other tool. But this presentation has barely scratched the surface of what Unity has to offer. We have specialized solutions for visualizing BIM data, for creating marketing materials, for machine learning, and for product configurators. So if any of that interests you, then please sign up for our free series of webinars at these links here. I'd urge you to attend. They're completely free. They're really informational. And yeah, we have a great time. So I'd really love to see you there. And finally, if you'd like to find out more about the products, or if you'd like to get going immediately with a free trial, then please do follow the product links here. You'll also be emailed a survey about this webinar, and I would love to hear what you think. So if there's anything you want to see next in our webinars, or you have any feedback, please do reply to that survey when you receive it. And finally, if you have any questions at all, don't hesitate to reach out to me via email or LinkedIn or Twitter. I would love to see what you create and how you're using Unity in your industry. Have fun creating. I think we have a few moments now for Q&A. So Drew, you can let us know some of the questions in the Q&A, and we'll go ahead and take a crack at answering them.
Alrighty, sounds good. Thank you so much, Antonia and Abdul Rahman as well for your presentations. They were fantastic. Alrighty, so yeah, we just have a handful of questions in the Q&A here today. First one up, I can only see out of one eye and VR is difficult for me. Do you know someone with monocular vision creating VR that I could connect with?
That's a great question. So I've looked a little bit into this, and in virtual reality, there's a few different cues that trigger the 3D vision. So the fact that if you move your head, you can have depth perception via that. So that there are ways to amplify these to make VR experiences more accessible for monocular people. I would actually urge you to go look up a talk by Elizabeth Barron. So she works here at Unity. She has a long history in VR. I think she's been working in virtual reality for decades. And I believe she has monocular vision as well. So she has a talk about that I think she gave at either a Unite or a VR and AR summit. I don't remember specifically, but I'm sure if you go look for Elizabeth Barron, you'll be able to find out more information on what she's done.
All right, awesome. Okay, the next one up. I have an Oculus, wondering if Weaver works with that.
Yeah, absolutely. So this demo actually that we have just created and demonstrated was also deployed and used on Oculus Quest 1 and the Quest 2. So right now, Weaver is supporting both devices. And in the future, in the next release, we'll be adding the hand tracking system that's coming from the Oculus Quest 2. We are very much excited actually about this because we see a major improvement between the Quest 2 and the Quest 1 for this hand tracking system, and we would like to add this interaction layer within the solution that we're providing here.
Another quick question. Just noticing all the options for VR during Antonia's presentation. What exactly is a cave system?
Oh, that's a great question. So a cave system is an immersive environment. It could be a typical kind of square room, or it could have a curved wall, and you have projected content on it. So kind of what it sounds like, I guess, a cave, but a room with projected content. So it's a little bit like virtual reality in that you're in a 360 environment, but it doesn't involve wearing any kind of head-mounted display.
Okay, excellent. Thank you. Is the Weaver Manager hosted in cloud or on premises?
Yeah, so the Weaver Manager can be hosted actually either on both. So it can be on cloud using AWS or the Azure, as well any other, let's say, cloud service that your organization would be using. It's kind of flexible interface because we have designed it in a way that it can be extended to any third-party system. So you can integrate these APIs with the service that you're using. And of course, it can be hosted on-premise as well.
Just a couple more questions here. Does Weaver support AR experiences?
Absolutely. So one of the values of Weaver is that you can build this content procedure only once and you deploy it for different platforms. So in that case, for a VR immersive training or an AR experience. So we're supporting the HoloLens 1, the HoloLens 2, the mobile devices, iOS, Android, and the PC as well, the VR devices in that case. So absolutely, you can build an AR experience as well. You can build VR experiences.
Question regarding Interact. What are their plans for Oculus Quest 2 and native hand tracking?
Not sure with regards to native hand tracking, but in terms of, I can certainly ask the Interact team that question for you. But in terms of Quest, Interact does support both the Quest 1 and the Quest 2 with an Oculus Link cable.
Just a couple more questions here. Does Interact work with Quest 1?
Yes, yeah, both Quest 1 and 2, as long as you have a link cable.
Okay, awesome. And I guess one more. What point cloud format does Interact support?
So ideally, you'll want .e57 or .e57. That's what's recommended, but it also supports .las format, .pts, and .ptx formats.
Well, looks like that does it for our Q&A. So thank you so much, everyone, for joining us for today's talk. Big thank you to Antonia, Abdulrahman, and Ellie, and our organizers as well. So please keep an eye out in the next couple of days as you'll be receiving an email with all of the resources and links from today's talk. There's also a survey coming your way. We really want to learn from you about how we can improve our presentations. So please fill that out and don't forget to register for our upcoming sessions as well. You can also check out our previous sessions in the series at resources.unity.com. And for additional information, you can subscribe to us on YouTube as well. So with that, thank you so much for joining us. Hope you have a great day, and we'll see you next time.